All right, good morning, everyone. So today what we're going to do is we're going to continue graphing inequalities. All right, so you could go ahead and take out or print pages 31 and 32 because these have graph paper on it, as well as your homework, which is on page 35. You don't have to, but it might help with keeping the numbers a little bit more organized and the graph a little bit nicer. All right, so let's go ahead and take a look at those problems. Right, so our key for today, so in fact, I'm going to cross this out. We're still going to look at linear, right? So no, we're not going to take a look at nonlinear quite yet. It's done the same way. You just graph it and then shade either side. But let's make sure we're solid on this. Right, so these are the two things we need to make sure we do. Is we need to be able to graph it, all right, and then decide whether the line is solid or dashed, right? It's solid if it's a less than or equal to or greater than or equal to, because that means the line is part of the solution. That's why we make it solid. It's dashed if we have something less than or greater than. That means the line is not part of the solution. And then, as always, we test a point to determine if the point that we test is true or false. If it's true, we shade that side. If it's false, we shade the other side. Right, so that's why it says shade the region that makes the inequality true. And we do this by testing a point. And the point that we tend to like to test is 0, 0. The only rule is you can't test a point that is on your line. There'll be problems with that. All right, but so far we haven't run into that situation yet. So what I'm going to have you do is I'm going to have you graph A, and then we'll check our answer. We'll graph B, check our answer, all right? All right, so go ahead and pause the video and graph that one and shade it. All right, let's see if you're right. So the first thing that we're going to do is plot the y-intercept, which is -1. And then we've got to decide, is it going to be dotted or solid? This is going to be dotted. Right, so that means I'm going to make a dotted line. So from here, I'm going to go down 1 over 3. And I'm going to make a dotted line. I'm going to go down 1 over 3 again, just so that kind of a funny looking dotted line, but that's okay. All right, now we're at the second part. We're going to test a point to determine what side to shade. So I'm going to test 0, 0. This is the point I'm going to test. I'm either going to write a true or false there. If it's true, that's the side I'm going to shade. If it's false, I'm going to shade the other side. So I always go back to my original equation or inequality, and I plug in my point. So 0 greater than -1. It is. That's true. So this is the side that I shade. If it were false, I'd shade the other side. All right? All right, let's look at the next one. Go ahead and try that one. All right, my y-intercept is 2, and then I'm going to ask myself, am I going to be a solid or dotted? This is going to be solid. So now I'm going to go ahead and go to my slope, which is 4, up 4, 1, 2, 3, 4, over 1. It's solid. Let me just go ahead and draw my solid line. So now I've got to ask myself, what side do I shade? I'm going to choose to pick the point 0, 0. So 0 less than or equal to 4 times 0 plus 2. 0 less than or equal to 2. That is true. So this is the side that I shade. Always shade on the side that's true, because this whole shaded region represents all of my solutions. So remember that assignment we did where we looked at if I tested that one, all of these will be true. All of these will be false. All right, let's try another one. let's check your answer. What am I going to write there? That is going to be dotted. Good. Let's go ahead and plot my point. 1, 2, 3. I'm going to go up 5. 1, 2, 3, 4, 5 over 2. And I'm not going to have enough room. I'm going to do one more. I'm going to just go the opposite direction. 1, 2, 3, 4, 5, and then back 2. And you can kind of see my line starting to form. Again, I'm going to test a point. I'm going to test 0, 0. And you can kind of see why 0 is nice. 0 kind of gets rid of that pretty quickly. So 0 less than 3, that's true. Would have been nice if one of them were false. That way you could see I would shade the other side, but I think you can get it. All right. All right, last one. This one is going to be solid. Good. Now, this form is different. This is not in y equals mx plus b. You can put it in that form and go ahead and graph it. But just remember, when you test a point, you want to test it back in your original. All right, I personally am going to just find the x and y intercepts. So the way I do that is I make x 0, I make y 0. So if x were 0, this would go away, and I'd end up with -5, right? Divide by -1. If y were 0, this would go away, and I'd have to solve this equation, 2x equals 5. So x equals 5/2. That would go here. Cool. All right, so those are the 2 points that I'm going to plot. 0, -5, and 5/2. That's just 2.5. I'm just going to go part way between there. No big deal. And it's a solid line. There's my solid line. Right. Now I'm going to test a point. Let's test 0, 0. So again, I always go back to my original equation to test my point. So 2 times 0 minus 0. This goes away, this goes away. So 0 less than or equal to 5. That's true. So this is the side that I shade. All right. All right, and that's it. Let's take a look at the next page. So this is an opportunity to just kind of jot down in your notes some big ideas. Right, so in your notes or learning log, explain how to graph a linear inequality. I'd probably include something along this line right here that we jotted down kind of messy. I might want to include number 1 and 2. So you might want to pause the video and write down this is how we graph an inequality. All right, and next, these are big ideas. So how do you know if your solution, if the line is part of your solution? Right, so this tells me lots of information. This tells me all my answers sit up here, but this dotted line also tells me something. It tells me anything, any point that is along that line is not part of my solution. So let's go backwards. How do we know if it's dotted? Well, if it's that symbol, greater than, or if it's that symbol, less than. So how can you determine if a line is part of the solution? It's part of the solution if it's less than or equal to or greater than or equal to, right? Because that means that it's going to include the line. It's not part of the solution if it's just a strict less than or a strict greater than. All right, another big idea is how do you determine which region the solution belongs to? So how are we communicating here where all the answers are? Well, it's based off of what I've shaded, right? So then how do we determine what to shade? We test a point on either side of the line. If it's true, that's the side we shade. If it's false, then we shade the other side. I typically test 0, 0, but I could test any point that I want. Right? All right, so let's take a look at the next one because I'm going to look at a case where people look at different points to test. So let's go ahead and just graph this. So the first point that I'm going to put, first of all, I know it's going to be solid. I'm just going to jot that down so I don't forget. I'm going to plot the point -3, 1, 2, 3, 4, 5, 1, 2, 3. I'm going to go up 1, 2, 3, 4, 5, 1, 2, 3, just so that we have a good picture. All right, so there's my line. So what's the minimum number of points you need to test in order to know which region contains the solutions? How many points have I been testing? I've only been testing 1 point. I've been testing 0, 0. So we only need to test 1 point on either side of the line. Right? So why is 0, 0 always the easiest point to test? Why am I always choosing that? Yeah, it's because I don't have to do any of the arithmetic. So when I plug in 0, 0, this goes away because 0 times anything is 0. So I end up with this. Is 0 greater than or equal to -3? Yes, it is. So this is the side that I shaded, right? Because that's true. Okay, so why is it, let's answer the question, why is it convenient? It's because it makes the arithmetic easy. Right? The arithmetic's easy to do because I'm multiplying by 0. Right? Our friend Anita decides to test a different point. That's fine, good for her. She can test that one. So -3, 2, 1, 2. This is Anita's point. I'll do Anita's point in purple. So now let's check. Where can I graph this one? All right, so let's take a look at problem number 52. So the very first thing we want to do is go ahead and determine whether it's solid or dotted. Well, because of this bar right here, we know it's going to be solid because it's going to include those points. And now we're going to go to -3. And we'll go down 5 over 3. 1, 2, 3, 4, 5 over 3. Then I'm just going to go up 5 over 3. 1, 2, 3, 4, 5, 1, 2, 3, just to kind of keep it clean. All right. So according to the directions, it says, what is the minimum number of points you need to test in order to know which region contains the solutions? Well, all along, I've just been testing 1 point, right? That's all we need to know, is we need to test 1 point. As long as we choose a point that's on either side, right? It's this side or this side, right? I don't want to choose points along my line. So Orville wants to use 0, 0. Well, good for Orville. Let's plug in 0, 0. We always go back to the original equation. So 0 greater than or equal that. And we end up with, why was I able to do that? Well, that's because when you multiply by 0, it goes away. So it kind of makes this arithmetic a little bit easier. So why is this point so convenient? It makes the arithmetic easier because I don't have to multiply stuff out. When I multiply by 0, stuff just disappears. So is 0 greater than 3? Negative 3? Yes, it is. So this is true. So this is the side that I shape. All right. But remember, I said you could test 1 point, any point. It doesn't have to be 0, 0. So Anita wants to use negative 3 too. Well, good for Anita. Let's see what happens when she chooses that. So negative 3, 2. Uh-oh. Okay, that's 1 point you can't choose. Right, so it says she decides to use that, test inequality with her point. I'm going to go ahead and test it. So x is negative 3, y is 2, so I've got to plug that in. And see, this is where it's a little bit more math. 5 times 3 is 15. Or negative 5, negative 3. It's positive 15 divided by 3 is 5. I'm going to show you, you could just cancel this out, right? So negative 5, negative 1 is 5. So we get this. Is 2 greater than or equal to 2? Yes, that is true. So I'm going to put a T here. It's true. Does that tell me which side to shade? No, it just tells me that's a solution. It doesn't tell me that where all my true values are. So that's why we don't want to choose points that are on the line. All right? All right, if you have any further questions, please make sure you ask, and have a great day.